In this lesson, we will look at how to create a computational attractor system using environmental data from Revit using Dynamo. As you can see in the background 3D preview on my workspace, the orientation of different panels are changing as my sun path in Revit updates. To get started, I am going to close Dynamo and my current Revit document to return to the Revit browser window. Since we will be using the sun path system, it is important to note that we will need to create a new project file. I'll turn on my sun path by clicking on the sun icon located at the bottom left corner of the Revit viewport. The sun path is a visual representation of the sun range of movement across the sky at a geographic location you specify for a project. Browsing to the Add-ins tab, I will launch Dynamo. To get started, I am going to locate the number node. I will use this to quickly define the sequence of x and y coordinates of a point. To define the sequence, I will use a start value 0, variable for my count, let's call this x count, and a variable for my increment, I will call this spacing. Notice that the inputs are created on the fly as variables that are used for our number node. Copy and paste the number node and change the x count to y count. From the search field, I will add a number slider and 2 integer sliders to my workspace. Connect the output ports of each slider to their corresponding input ports. Rename the integer sliders xCount and yCount so that it is easy to identify their associated use later on. To do this, right-click on the integer slider and select Rename Node. I will repeat this process for the number slider, giving it the name Spacing. Next, I will add a point by XY coordinate to the workspace. I will do this by browsing to Geometry, Point, Create. I will choose the point by coordinate specifying x and y. Let's connect the output of our number nodes to the x and y input ports on our point by coordinates node. Remember that you may use Ctrl B to navigate the background 3D preview. Pressing Ctrl B once more will return you to the definition. I would like for my points to be structured as a grid, so I will right-click on the point by coordinates node and change its lacing to cross product. Changes made to either the x or y count will now be displayed automatically. I will now use the collection of points to define the center point of a circle. Browsing to Geometry, Circle, Create, I will add a circle by center point, radius, normal. This node provides an easy way to orient the circle using a directional constraint. Let's connect the output of the point by coordinate to the center point and add a number node to define the radius of our circle. To define the orientation of the circle, I will browse to Geometry, Create. I will use the Z-axis to define the world up. Although I was successful in creating my circles, the ultimate goal is to create a field of diamonds. In this case, the circle by center point radius normal is really just an intermediary geometry that I will use to circumscribe a polygon. Browsing up to Polygon, I will create a regular polygon. A regular polygon requires a circle input and a number of sides. I will use a number node to define the 4 sides. To manage what is seen in the background 3D preview, I will right-click on my circle by center point radius normal and turn its preview off. Navigating the background 3D preview on my workspace, I can see that my polygon preview has gaps. I would like to fill the gaps with additional polygons to form a continuous field of geometry. To create a continuous grid of polygons, I will need to create a second grid of offset points and add them to my list of center points. I will copy my number nodes and point by coordinates node and paste them. Notice that in order to be able to define an offset grid of points, I first need to understand that my spacing is establishing the distance between each point. In order to create a new point offset, I will need to be able to establish a relationship between the spacing and the points. I will disconnect the input ports of both my number nodes and make a slight modification. To define the offset amount, I will need to multiply the spacing value by 0.5. This will ensure that our second grid of points is offset by a value related to the global grid spacing. The multiply node is located in the operators category of the node library. Using a number node, I will define a value of 0.5. I will now multiply the spacing output by 0.5 and connect this output to the offset in both the x and y sequence. Once this is connected, you will see that there is a new sequence of points. Make sure at the bottom right-hand corner of our new point coordinate node that the lacing indicates that cross product is selected. If it is not, right-click on the point by coordinates node and change its lacing functionality to cross product. Now that we have two grids of points, we can create a new list merging them together. This will allow us to send both sequences to the circle node simultaneously. I will disconnect the input port of the center point and search for a list create node. The plus or minus icons on the list create node allow you to create additional input ports. Let's connect both point by coordinate nodes to index 0 and then index 1. This will create a list composed of both sets of points. We can now connect the output of this list to the center point input port of our circle by center point radius normal. This basic definition automates the task of creating a grid of diamonds. Navigating the background 3D preview, we can see that making changes to any of our number bodies will result in a new solution. In this case, I have triangles or quads, and I can modify their spacing. Additionally, I can make changes to the number of panels in both the X and Y direction. I would now like to replace the constraint Z direction in this definition with a more dynamic input. Searching for the sun path, I'll see that Dynamo has a node to select the Revit sun and return its direction. Click to add this node to the current workspace. Let's use the sun path direction node to define the normal direction of the circles node. I will do this by replacing the vector Z axis with my sun path direction. I will also connect the output port of the regular polygons node to a surface patch node to more clearly represent the orientation of the panels. Browsing to Geometry, Surface, Create, I will click on By Patch to add this node to the workspace. Let's connect the output of the regular polygon to Close Curve. Navigating the background 3D preview, I can now see my panels more clearly. To thicken the panels, I will add a Surface Thicken node. From Surface, I will open up the subcategory Actions and browse to Thicken. I will connect the output port of my Surface Patch node to the input surface of Surface Thicken. Using a number node, I will modify the amount the surface is thickening. In this example, I will use a value of 0.1 to define the thickness of the panel. Additionally, I will resize my Dynamo window so I can see both Revit and Dynamo simultaneously. Collapsing my library, I will have a little more screen real estate in Dynamo to see the updates that I'm about to make. In Revit, I will modify the sun settings, and once again we will see the live updates in Dynamo. This will allow me to quickly understand the impact of the sun's position on my array of panels.